Good day everyone. Welcome to the module Embedded System Design. So at the end of this lesson, you guys can able to understand or get an idea about this module, and you can understand the basics of embedded system and also the overall outline of each units. That is about the course outline. And also I have included the assessment type and the reference book. So now straightly let's go to the topic, what is embedded system. So what do you mean by embedded system? Embedded system, it is a combination of software as well as hardware. So the example of hardware is microprocessor. The example of software can be an embedded system C language. So with the use of hardware as well as software, when it put together, what comes, it forms an embedded system. Or you can say the embedded system is intended design to perform a particular task. So what do you mean by particular task? A particular task is one that should be completed within a particular deadline. Usually the particular task can be learned in real-time operating systems. So now also you can define the embedded system as it is used with one or more sensors, with one or more microcontroller and a microprocessor. So now what do you mean by microcontroller and a microprocessor? A microprocessor is also called as CPU, that you all know, right? So now what do you mean by, in general, what do you mean by microcontroller or a microprocessor? A microcontroller is a device that contains microprocessor, but the microprocessor is the one which cannot contain microcontroller. That is the main difference. Let's move on to the next slide. So now you can see this is the overall block diagram of embedded system design. So this is the general block diagram that covers some input devices, output devices, power supply and memory devices. And along with everything it comes the microcontroller. Microcontroller is a device that controls all other components. So now what do you mean by input device? Something you are feeding to the microcontroller. So microcontroller will be the brain of the embedded system. So when you feed some input to the microcontroller in turn it processes and it produces an output based upon the input. The input, it may be a keyboard device or it may be a sensor device, or the output, it can be a screen or it can be even a buzzer. So for working with the input as well as the output device, the main thing what is necessary is the power supply. You know, all the electronic devices can work only with the help of power supply. So power supply is the basic component which can be included in all the embedded system design controllers. And not only the input device as well as the output device, it also comes with memory device. So what do you mean by memory device? The memory is the one which can either store the temporary data or permanent data. The example of storing the temporary data, it can be a cache or it can be a RAM. An example of permanent data, it can be ROM devices or PROM or EEPROM. There are many things. So nowadays the controller, it comes with flash memory devices. So this microcontroller can be any kind of microcontroller. For example, it can be an 8051 microcontroller, or it can be an ARM microcontroller, or it can be an advanced RISC microcontroller, or any kind of microcontroller. And now when you talk about the microcontroller, it says about the number of bits. So for example, each and every microcontroller, it works according to the amount of capacity it has. For example, 8051 microcontroller can operate only for 8 bits. PIC microcontroller can operate either for 8 bits, and advanced PIC microcontroller can operate for 16-bit PIC. Or ARM microcontroller, the lower version it may be of 32 bits, or higher it may be 64, or it may operate for 128 bit. The well-known example of an embedded system is your mobile phones. I mean the smart mobile phones. All the smart mobile phones, it comes with microcontroller, and also you are using some kind of input devices. What input devices you are using? With the help of the touch screen, you are inputting some signal to the microcontroller, and at the same time you can see some output with the help of the screen also. And microcontroller is such a application, or embedded system, it is such an application where you can put on in all the electronic applications. So now let us say some of the applications of embedded systems. Let's say micro motor control system to control a motor, engine safety, entertainment and multimedia in car, mobile access, robotics, wireless communication, mobile computing network are some of the applications of embedded systems. So now, as I said in the beginning, there is a difference between a microcontroller as well as the microprocessor. So what is the difference between microcontroller and a microprocessor? A microcontroller, it is the master of embedded system, and it is the master of controlling all the components. And I said microprocessor is also one of the component which is present in the microcontroller. So now let us see the difference between microcontroller and the microprocessor. Microcontroller is designed for special purpose. Microprocessor is designed for general purpose. So that means microcontroller contains special function registers. Microprocessor contains general purpose registers. Microcontroller is intended to do specific task. Microprocessor can do multitask. That means it can do the calculations, it can the arithmetic, can do the arithmetic, logic operations, everything. But microcontroller, it does only the specific task. And microcontroller is software protected, whereas the microprocessor is not software protected. And microcontroller occupies less space, whereas the microprocessor occupies more space. And when you compare the microcontroller is a low power consumption device, microprocessor is a high power consumption or more power consumption device. So these are some of the difference between microcontroller as well as the microprocessor. So now let us see how the embedded system is used in real-time applications. So generally, what do you mean by real-time applications which respond to a particular task? A real-time application is one which respond to a particular task. So what is task? A task is a piece of job that should be done in a period of time, or you say it can be an interval of time. So now when you talk about an interval of time, it ends with a deadline. A task is the one which has its own deadline. So we are supposed to finish the task within a particular deadline. So what do you mean by deadline? Task should be completed in time. That is called as deadline. So now the real-time applications can be divided into two groups, soft real-time as well as the hard real-time. So what do you mean by soft real-time? Soft real-time is the one which can accept few deadlines, deadline misses. So that means there is a deadline. Even in the case if the deadline is not properly covered, it doesn't make any damages. For example, it may be a mobile phone. When you're taking a picture in the mobile phone, it may take 2 or 3 seconds a delay because of your uh, maybe the memory is full. Because of that reason, the camera may be operating in a delay of 2 to 3 seconds. Nothing is going to be wrong when the camera operates 2 to 3 seconds delay. So that kind of delay which is acceptable is called as soft real time. The another real time which is called as hard real time, where the task should be completed within the deadline. If not, what happens? It may creates a damage. It may results in a damage. Example, a missile launch or a spacecraft, so something like that, or it may be an scanning machine. If the radiation is exposed much, what happens? Or if the hard real-time system doesn't meet the proper deadlines, what happens? A damage will happen to the human beings. So the deadline, it can be the task can be soft real time or it can be a hard real time. Okay, so I think now you can get an idea about the overall idea about embedded systems. It has too many applications, as well as you can program your dreams. Whatever, if you are assigning some inputs, you can make it in a real electronic device. So the main example of embedded system is Arduino device. So Arduinos, it is like a playway kit. You can play with by programming the Arduinos. What happens? You are programming something. You are giving some input by means of what? A program. A program means you are talking about what? A software. So when you are giving some kind of input to the embedded system components, what happens to the hardware devices? The hardware devices respond to the software. That's what you call embedded system is a combination of hardware as well as software. Writing a program and making the hardware to operate as the software instructs. So now let us go to the course outline. So totally you have 5 units for this module. The first unit, it covers about embedded system design process. So embedded system design process, it covers the following topics, that is requirement specification, architecture design, designing hardware and software components, and system integration. So these are the steps required for embedded system design process. What are they? Requirements, specification, architecture design, designing hardware and software components, and system integration. Even in your phase 1 of your project, you may apply some of the things from this unit. So you should be very careful and listen carefully when we are talking about unit 1. It may cover or it may help you for phase 1 also. Then after the steps required for the embedded system design processes, we are going to talk about formalism of system design as well as structural description and behavioral description after formalism of system design. So these 3 topics, it talks about some of the schematic representation which is very important to design a particular thing. It may be the schematic, it may be a reflection of some software types, but still you can make use for designing or coming up with some schematics which is useful for designing a particular process. So all those things will be covered under unit 1, that is embedded system design process. So the next unit is about instruction sets. So instruction sets, it covers about ARM microcontroller, that is advanced RISC microcontroller, then PIC, peripheral integrated circuit microcontroller, especially micro mid-range family, and also it has TIC555H DSP, it is a processor kit, as well as memory system mechanism, CPU performance, power consumption. So out of this we are going to see only the ARM microprocessor, I mean ARM microcontroller, as well as the PIC micro mid-range family. So since you are going to learn about two different microcontroller family, I don't think that you will be having some time to discuss about this digital processes. So we are going to skip this topic from our syllabus, so that we are going to learn about two microcontrollers along with the memory system mechanisms, and also CPU performance and power consumption, which comes under instruction set. So now for the labs also, we are going to see all the experiments with the help of PIC mid-range family only, that is PIC16F877A microcontroller. So now unit 3, it contains hardware and software system design. So it covers various topics such as basic computing platforms, CPU bus, memory devices and system, designing with computing platforms, consumer electronic architecture, models of the program, assembly linking and loading, compilation techniques, program level performance analysis, software performance optimization. So you have numerous number of topics under unit 3. Out of this, the basic computing platform will be very easy, CPU bus, these things and all, it is very easy to read. And designing with computing platforms, it covers too many pages, but also we have taken some important points. I have already prepared the notes for you, so this time this module, it will be bit easy when you see the notes what I have compiled. And I will be forwarding the book what mainly we are using for this module. That book also I am going to forward to you. Then it talks about consumer electronics architecture. So each and every topic is very important. We are not going to ignore any of the topic from unit 3. And unit 4, it talks about process and operating system. That means it mainly focuses on real-time operating systems. So now under this topic you will be learning about the multiple task, multi-rate systems, and the scheduling systems, scheduling processes. What are the scheduling processes present under the software systems? That means it may be a preemptive scheduling or a priority based scheduler or inter-process communication, everything. It talks about a scheduling process. So all those things are discussed in unit 4. And unit 5, it talks about system design methodologies, where we are going to see about design flow, then CRC card, quality assurance technique, verifying specifications. So control oriented specification language we will be seeing later once we are covering all those topics, because this topic is a bit different. It doesn't have any continuation with other topics. That's what I put it later. Okay, so these are the 5 units. Out of these 5 units, I have to say that each and every unit will be a bit clumsy. That means it has more things for you to read. And when you come for an understanding, like if you're reading 10 lines, you can write 5 lines. So this, for this semester, especially for this module, you're going to read too many things, and after that you will be writing. That means you will understand what you're reading and then you will be writing. So it is not a hard module, but you cannot ignore this module like just like that, because you have to weigh this module as like if you are reading everything, you can understand. That's what I say. The reference book also, the author is very open, and he has written his words like talking with us. So that means he is talking too much in this book, but after he communicate with us, you will be writing one or two few points. You will be grabbing 2 or 3 points from what the author is coming to say. So it is a much interactive book. Also, when you compare the overall thing about this module, it is not like digital electronics. It is not a mathematical oriented paper. It is a pure and pure theory paper, but you cannot underestimate this paper because this is the advanced form of microprocessor. So that means microprocessor, according to me, you can say it is very easy for you, but embedded system design, it depends upon you only, right? I hope you have understand, or you have got the overall thing about embedded system. So now when you go to the textbook, what kind of textbook we are using? Computer as components, only one textbook. So if you have more time, please go and read the textbook. I'll be sending through Google Classroom or WhatsApp group also, but I have compiled some notes for you. So if you don't have that much time to read the overall book, that means you can go ahead with the by reading my notes also. Okay, so that's all for today. So from next class we will be straightly going to unit 1. Okay, thank you guys, have a good day. These are some of the revision questions. What is an embedded system? Difference between microprocessor and microcontroller, input and output components. All those things, they are very important, 2 mark or 3 mark questions. Thank you everyone.